The OSI model describes how a data transfers over the network from one computer to the other and the way the systems send information to one another. In order to accomplish a successful communication between computers, there are 7 distinct layers which are interconnected and which work closely to make the communication happen. That is why it is called the Open System Interconnection Model or the OSI 7-layer model. The purpose of this model is to enable functionality and interoperability between different vendors and connectors. From a design point of view, it divides larger tasks into smaller, more manageable ones. The 7 layers of OSI model are: Layer 1, Physical Layer. Layer 2, Data Link. Layer 3, Network. Layer 4, Transport. Layer 5, Session. Layer 6, Presentation. Layer 7, Application. Data flow example. This is how data flows through the OSI model. For example, if you send an email to a colleague or friend, your email has to pass to presentation layer via application layer. The data gets compressed at this layer. Next is the session layer, which initializes communications. It will then be segmented in the transportation layer, broken up into packets in the network layer, and then into frames in the data link layer. It will then be sent to the physical layer, where it is converted to zeros and ones and sent through a physical medium like cables. When your friend gets the email through the physical medium, the data flows through the same layers, but in the opposite order. The physical layer will convert the zeros and ones to frames that will be passed to the data link layer. This will reassemble the frames into packets for the next layer. The network layer will assemble the segments into data. The data is then passed on to the presentation layer, which ends the communication session. The presentation layer will then pass the data to the application layer. The application layer feeds the human-readable data to the email software that will allow your friend to read your email. Application layer. The application layer is where the user interacts with a software application, so it is closest to the end user. This layer interacts with the application communicating with the network. Application layer is used by network applications which rely on application layer protocols like HTTP and HTTPS to function. The applications that use these protocols are browsers: Firefox, Google Chrome, Outlook, Skype, etc. There are many application layer protocols that enable functions at this layer. All these protocols, collectively called application layer. Application layer provides services for network applications. With the help of these protocols, users are able to perform activities like sending emails, file transfer, web surfing, etc. File transfer is done with the help of FTP protocols. For sending emails, SMTP protocol is used. Web surfing is done with the help of HTTP or HTTPS protocol. And for virtual terminals, Telnet is used. Application layer provides services for network applications. Presentation layer. Next to application layer is the presentation layer. This layer is responsible for ensuring that the data is understandable for the end system or useful for later stages. It translates or formats data based on the application's syntax or semantics. It also manages any encryption or decryption required by the application layer. It is also called the syntax layer. Next to application layer is presentation layer. Presentation layer receives data from application layer and converts conversion of ASCII code to machine code or language. This function of presentation layer is called translation. Encryption enhances the security of sensitive data at sender side. Data is encrypted at the receiver side. Data is decrypted as protocols, or secure sockets layer protocol is used in presentation layer for encryption and decryption. So presentation layer performs three basic functions: transmission, compression, and encryption/decryption. Session layer. The session layer will create communication channels called sessions between different devices. This layer is responsible for opening those sessions and ensuring that they're functional during data transfer. In other words, the session layer is responsible for establishing, managing, and terminating communication sessions with the lower layers with the presentation and communication layer. It is also responsible for authentication and reconnections, and it can set checkpoints during a data transfer. Transport layer. The transport layer is responsible for delivering, error checking, flow control, and sequencing data packets. It regulates the sequencing, size, and transfer of data between systems and hosts. It gets the data from the session layer and breaks it into transportable segments. Protocol from transport layer or transmission control protocol, or TPT, and user datagram protocol, or UDP. Transport layer performs two types of services: connection-oriented transmission and connectionless transmission. Connection-oriented transmission is done via wire connection. This transmission is done by UDP. UDP is faster than TCP because it does not provide any feedback whether data has really transferred, whereas TCP provides a feedback. Therefore, load data can be retransmitted in TCP. Layer 3. Network layer. The network layer receives frames from the data link layer and delivers them to the intended destination based on the addresses inside the frame. It also handles packet routing. The network layer locates destinations using logical addresses like the IP. Routers are a crucial component at this layer as they route information to where it needs to go between different networks. The main functions of the network layer are routing. The network layer protocols determine which routes from source to destination. Logical addressing. The network layer defines an addressing scheme to uniquely identify devices. The network layer places the IP addresses from the sender and receiver in the header. Layer 2. Data link layer. The data link layer corrects any errors that may have occurred at the physical layer. It ensures that any data transfer is error-free between nodes over the physical layer. It is responsible for reliable transmission of data frames between connected nodes. The data is packaged into frames here and transferred node to node. The data layer has the following sublayers. Media Access Control, MAC. The MAC address layer is responsible for flow control and multiplexing devices' transmissions over the network. Logical Link Control, LLC. The LLC layer provides error control and flow control over the physical medium and identifies line protocols. Layer 1. Physical layer. The physical layer is responsible for transmitting unstructured data bits across the network at the lowest layer of the OSI reference model between the physical layers of the sending and receiving devices. In other words, it takes care of the transmission of raw bit streams. The physical layer may include physical resources like cables, modems, network adapters, and hubs, etc.